Hi grade 4s. Today we're going to be talking about a type of gear called a spur gear. So these are the most common type of gears. They have straight teeth that point out from a circular shape. There's a hole in the center that can be used as its axis. That means the point by which it turns. And they're used in many different devices, including electric screwdrivers, clocks, washing machines, clothes dryers, or even wind-up alarm clocks. Although you won't find very many of these in a car. This is because the spur gear can tend to be very loud. Each time the gear's teeth mash together, they make very loud noises because obviously they wouldn't be plastic. In a metal gear train, the gears do make quite a lot of noise. So we're going to look at how these gears work, and I'll explain a little bit about what they mean as well and how they can be useful. Okay, so this is an example of a gear train. You'll notice that there are 3 gears. Each one is a different size. On each of the gears, there's a couple of things that I want you to notice. First, there's these spokes coming out of the side of the gear. So those are called the teeth. At the top of each gear, you'll also notice a little triangle. So that's what we're going to pay attention to in this lesson today. So watch carefully as we spin the green gear. This is called the driver gear. It's called the driver gear because that's the one that's receiving the energy. The other 2 gears in the gear train are called the driven gears. That means that they are moved by another gear. So when I turn the green gear, watch which direction it goes. So I'll be turning this one clockwise. So that's 1 full circle. So let's go back 1 full circle this way. And watch which direction the yellow gear turns. So again, I'm going to turn the green gear in 1 full circle clockwise. Watch the arrow at the top to help you figure out which direction the yellow gear is going. So we can see that when I rotate the green gear clockwise, the yellow gear moves counterclockwise. That means they're moving in opposite directions. Now let's use the same example, but looking at the blue gear, the smaller gear in our equation here. So when I turn the green gear clockwise, the blue gear also moves clockwise. That's because there's another gear in between. So it changes direction each time. Clockwise, counterclockwise, and clockwise again. Now let's look at the speed. So now I'm going to turn the green gear in 1 full clockwise circle. We're going to watch to count on the yellow gear how many times it moves around in a circle in the same time that it takes the green gear to turn 1 full time. So that's 1. And it's just past 1. So we can see here, if it was 1 full circle for the yellow gear, the yellow triangle would have stopped up here. But it's actually over here. So this means that our yellow gear has moved 1 1/4 times when the green gear moved only once. Now let's do the same thing with the blue gear. So watch carefully as I turn the green gear in 1 full circle clockwise. So that's 1, 2, and a half. So our blue gear moved 2.5 times for every single rotation of the green gear. Let's look at why. On my green gear, let's count the number of teeth. So we have 1, 2, 3, 4, 5,
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49.
50 teeth on the green gear. Let's try with the yellow. So remembering the green gear had 50. On the yellow gear, we have 1, 2, 3, 4,
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39,
40. And on our blue gear, starting at the top again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our gears have 50, 40, and 20 teeth. Using our gears as an example again, let's this time take a look at the speed at which the gears turn. When I turn the green gear, you'll notice that it moves at 1 speed but the blue gear travels much faster. It does not require as much effort to turn the green gear because I only have to turn it once for the blue gear to turn 2.5 times. If I were to do it the other way, I would have to put a lot more effort into turning the smaller gear in order to get the green gear, the larger one, to move just as far. When different sized gears mesh together, there is what's called a gear advantage. When the large gear turns a smaller gear, the small gear will rotate quicker. This advantage is called gearing up. It takes a lot less force for me to rotate the large gear and make the small gear turn more. For example, our green arrow is at the top here. If I rotate this gear in one full circle, you'll see that the blue gear turns 2.5 times. So it's moving farther, but with less force. On the other side, if I were to turn the blue gear in one full circle, watch what happens to the green gear. In this case, the green gear didn't even make it to 1/2 turn. This is called gearing down. When a small gear turns a larger gear, the large gear will rotate slower. The speed that the gears rotate depends on the number of teeth for each gear. Different sized gears provide a mechanical advantage. In this case, our small gear has 20 teeth and the larger gear has 50. That means that the larger gear moves 2.5 times the speed of the smaller gear. So that's our lesson on spur gears. Take a look at the worksheet today and see if you can apply what you've just learned.